recording here. Okay, so today we'll happy Friday, everybody, and we will in class today. What we'll do is we'll take a look at Jupiter. Okay, and so once again, what I want you guys to do, if you haven't done so already, is to download Anaconda and install it on your machine, and that should get kind of Python and Jupiter and NumPy and pandas and all of that stuff will get loaded onto your machine. Okay. And so what I like to do is I like to just start Jupiter by opening a command prompt. Okay. If you're on a Mac, you'll open just a terminal window. Okay, you can just search for terminal and open up that. You'll probably want to navigate to the drive that you're going to be working in. And then to get started, you'll type in Jupyter Notebook. Now, before I do that, however, one thing I want to encourage you to do is to get in the habit of trying to update your packages and software. Okay, and you can do this by doing conda space update -- all. Okay, conda update all, and I'm going to go ahead and hit enter right now, and then I'm going to hit no that I don't want to do it because it's going to take a little bit of time. But when you do that, it's going to go through and it's going to oh, it looks like it's stalling here. It should say solving environment and checking to see if any of the packages need to be updated or things like that. And you should do this, at least every couple of weeks to kind of make sure that that your packages are up to date. Although I seem to have, something's not working for me. Let me try this again. Okay, let me just see. Conda update -- all. Okay, I don't know, something weird is happening, and it doesn't seem to be working on my machine. All right. Well, this is awkward. Okay. Well, I hope I don't have to reboot my computer. Let me just see if I can get Jupyter Notebook running. Okay. Let me navigate. Okay, and so to get Jupyter Notebook started, you'll just type in Jupyter space Notebook, and that will open up most likely your web browser, and it will look kind of like this. And then you can kind of go into the folder that you want. And so I'm going to work in 2019 Spring Stats 131, and over here, let me actually I'm going to open up a Git bash window. You can open up another terminal thing, and let me just check Git status here, and let me add this. Okay, and so if you want, you might be able to fetch the changes made to my GitHub repo and the notebook that I've just created for 2019 Spring here. Should have the this notebook 0102. I'm sorry, I should say 0103 0103 Jupyter and IPython Basics for week 1, Friday. Okay. So anyway, here we are, and within Jupyter, okay, we can create notebooks. Okay, so notebooks are files that allow us to kind of combine cells of code that run along with cells of markdown. Okay, so I'm going to go ahead and I'm going to click create a new notebook, and I'm going to create a Python one. Jupyter supports other languages, and you can install the kernel to create R notebooks, and it will be similar to an R markdown file, but it will be Jupyter, which has native support in GitHub, which is nice. But anyway, once you have Jupyter running, you'll go ahead and just come over here to New, and you'll click New Python 3 Notebook. Okay, and so that will create something like this. All right, and so I'm going to just kind of rename this to be 01-03, and I'll call it in-class demo. So that will be the notebook I'm creating. And here, this is a cell, and you can type in code here and execute it. Okay, so I can say, let's do 3 times 5. Whoops. 3 times 5, and you can click this button right here, and that will run this cell, and it will say 15. Okay. Are you guys attempting to follow along or not? I don't know. If you're attempting to follow along, the way I got here was from Jupyter. We just went to New, and we did Python notebook. Okay, and then you'll start off with kind of a cell. And once you have a cell, you can click this plus button for insert a new cell. Okay, and that will insert a cell below it, and you can run something else. You can say something like print hello. Okay, and then you'll click run the cell, and it prints out hello. Okay, so nothing too exciting there. There's a few shortcuts. Okay, on the keyboard, you can move from cell to cell by using J and K. All right, this has to be blue. There's the Jupyter Notebook has 2 modes. It's got command mode and it has edit mode. Okay, command mode means you're kind of taking command of the entire notebook, and you're trying to scroll through the notebook, add cells, things like that. And edit mode, when you hit enter while you have a cell selected, it will enter the cell and you can edit the contents of the cell. Okay, and you hit escape to exit command mode. So there's a few keyboard shortcuts. If you wanted to add a cell below, you can type just the letter B. When you're in command mode, while this part over here is blue, you can just type the letter B, and that will insert a cell below your current location. Okay, and so you hit B, it inserts a cell, and we're going to do something like X is equal to 10, Y is equal to 5, and I will say, print X times Y. Okay, and so this is going to be the code that I want to run, and if you want to run it, you can just hit Control Enter, and that runs the cell. Okay, so you can click the little play button next to it, or you can click this button up here that says Run, or you can hit Control or Command Enter, and it will run the cell that's currently selected. And after you run the cell, it automatically switches back to command mode. The left side is blue. Okay. Again, we can navigate by hitting J or K to go up and down, and this just allows you to keep your hands on the home row without having to move your hands over to the arrows. Okay, so just get used to J and K for going up and down. B will insert a cell below. If you have the cell selected and you're in command mode, you can also hit A. A will insert a cell above, okay? So you can insert something above here. And I don't know, you can do something here, all right? There is a, so you can run code, and sometimes you don't want to run code, you want to enter commentary. You want to talk about the results that have been printed, right? Much like in our Markdown, in the notebook, you want to be able to combine code and its output along with some comments or commentary. Not just comments. With comments, you can use the hash mark to comment out a line of code, but you might want to actually switch into Markdown mode, okay? And so Markdown allows you to enter paragraphs and headlines and bullets and things like that. To switch to Markdown, while you have a code cell selected, you would come up here and you would choose from code. You can switch to Markdown, okay? Or you could switch it back to code. There is a shortcut, okay? You can use the letter M to switch to Markdown, and the letter Y to switch to code. So while you have the cell selected in blue, okay, you can type M for Markdown and Y for code, okay, and that's the same as coming to this menu up here and choosing, okay. When you're in edit mode, once you hit enter and it's green, okay, M and Y will not change the mode because you're entering text, right? But this allows you to, you can enter text. You can use a pound mark, so a single sign will make a heading. Two pound signs will make a subheading, and then you can also make bulleted lists with asterisks. Okay, so you can do star, or is it maybe dashes? Maybe both. Maybe both are allowed. Okay, so you can say item 1, item 2, item 3. Okay, and so this is what it looks like. And then when you're ready for it to render, you click run. You run the cell or you hit Control Enter, and when you run it, it formats the text, okay, into kind of the bulleted list here. Is this okay? So this is how we will be doing most of our work in Python. Okay, you can write scripts and separate documents and things like that, but the Jupyter Notebook is quite a handy interface for us to kind of interact with Python. Okay, so I've prepared a notebook with a little bit more stuff, and this is the Jupyter and IPython basics. Okay, so so Jupyter is the notebook, and it runs on top of IPython. IPython is kind of stands for interactive Python, and it's a version of the Python console that has a few nice features over the base version here. Okay, so here I have a cell that just says Jupyter, and I can navigate through it using J and K to kind of move from cell to cell. And these have already been rendered or have been run. And again, so we just kind of have talked about this. So Jupyter has two modes: command mode, where the left of the cell is blue, and edit mode, where the left of the cell is green. So again, to enter edit mode, you hit enter on your keyboard, and it allows you to kind of edit the text that shows up in there, and then escape will switch to command mode. Okay, if you enter edit mode and then you hit just escape, it will look like this. It will be kind of your raw markdown. And if you want it to render, okay, you have to run it. Okay, so you either hit run or you hit Control Enter, and it will run the cell. Okay. Okay, so we talked about adding cells using the letter B to add a cell below your current cell, and A to add a cell above. If you want to delete a cell, okay, so if you've created something over here, and so while you are in command mode, okay, so obviously if I'm in edit mode and it's green, if I want to delete the cell, the command is DD. You have to type the letter D twice, okay? And so if I type DD here while I'm in edit mode, I'm just entering the letters D into the cell, okay? So we don't want that. I have to escape, so I'm in command mode where I'm blue, and then if I hit DD, it deletes the cell, okay? You can undo by hitting Z, okay? So you don't have to like hit Control D or Control Z, it's just you hit D twice, DD will delete it. If you want to undo something, you hit Z, okay? And that puts the cell back there, okay? You have to be careful that you don't get command mode and edit mode mixed up, because if the danger, so if you're in edit mode and you start typing things like keyboard shortcuts for command mode, it's not a big deal because it's just going to enter the text into the cell and you'll realize, oh, that's not what I intended to do, right? Like if you want to type in the letter X here, or if you intend to run Command X and you type in the letter X, it just puts in an X into the cell, and that's easy to undo. Okay, you just hit Z, or you just hit backspace, and it's not that big of a deal. However, if you're in command mode and you type the letter X, X stands for cut. Okay, so maybe I thought, oh, I wanted to just go in here and enter the letter X because that's my variable name or something like that. Well, by hitting the letter X, I have cut that cell. Okay, and that might not be something you have wanted to do. So just be careful that, you know, if you wanted to type the letter X into a cell, that you're in edit mode and not command mode, because command mode will interpret X as cut, like cut, copy, and paste. So you can hit X to cut the cell and then come up here and paste the cell, okay? Or you can copy a cell with C and things like that. You don't have to hold down Control or Command, just type in the letter. Okay. Navigating, you can go up and down just by typing J or K to move up or down. And then, and Jupyter supports different kinds of cells, code, markdown, and also raw types and headings. And I would say the main things that we use are just the code and the markdown, okay? And you can switch from markdown to code and back and forth by using the letters M and Y. M for markdown. I don't know why Y is code, okay? I'm hoping by this point you are familiar with Markdown, okay? And there's a few things here that, and I've intentionally put this. If you use these tilde things, it indicates just verbatim, meaning just let things appear the way they are. And I have to do that, otherwise it's going to render these things as headings and whatnot, right? So so you use the hash marks to indicate headings. One hash will be a single top level heading, and 2 will be a secondary heading, and you can go up to 6 for to count as, you know, a 6th level heading, and it's just you can kind of, if I insert a cell, switch to Markdown here, this will be heading level 1. Oops. And we got heading level 2 for heading level 3. And by the time you get to the 4, 5, they start hitting level 6, and it will not support any more than that. Okay. So this is heading level 1, 2, 3, 4, 5, and 6. Actually, they're different levels, but they kind of get rendered the same, and after that it just becomes normal text. Okay. So those are the different things. You use little dashes or hyphens for bulleted lists, and then you can make equations using the double dollar sign. And I think we're familiar with this, right? So if I want to do here's an equation. You use double dollar sign, and you say something like E equals MC square. All right, and then you hit Control Enter to render it, and it turns into equations. Okay, asterisk stars are for emphasis. So 1 star on each side will italicize, and 2 stars on each side will make it bold. Okay, and then if you want literal or things with to be look like code, you can use the back accent character or 3 tildes, and that's just kind of a brief rundown of Markdown stuff. Okay, we can run the Markdown cell or the Python cell, okay, with Control Enter or Command Enter, and that will just run the current one. And then, but Shift Enter is probably the one I use most of the time. What that will do is it will run the cell and then move on to the next one. And if you're at the bottom of the notebook, it will run the cell and automatically insert a new cell below. Okay, so if I'm over here and I make some changes and I would say X is 10 and Y is 2, okay, I can hit Shift Enter and it will run that cell, and then it will automatically enter the next cell for me. Okay, and I can say name equals Miles or something like that, and that gets saved over here, and then I can ask print name, and it will print out my name and stuff like that. Right. So Shift Enter will run and move on to the cell below, and if you're at the bottom, it will insert a cell below. So that's probably the one I end up using the most, but Control Enter is the equivalent of just clicking one of the cells and clicking Run. And then at any time you can also just hit H, and this will pull up a screen of kind of some shortcuts which are handy. Okay, so in command mode, you know, we have different things, right? Like change to code and markdown, and different stuff above, insert above, and things like that. So these are, I think I've listed off the ones that I end up using the most. Okay, and then edit mode is, while it's green on the left, you can kind of use any of these shortcuts to help you write faster and things like that. I think all of these are kind of similar to commands that exist in a word processor, right? Like Control Right moves one word to the right, and Control Backspace will delete words at a time rather than just letters at a time. And those shortcuts exist in, you know, just Microsoft Word as well. Okay, so here I have a few things in IPython that we can do as we run some code here. Okay, so here we've got you can do a basic operation, and as always, you can write comments by preceding them with kind of a hash mark. Okay, and so I'll go ahead and I'll run this. This time I'll just, so I'll hit Shift Enter, and it says in 1, 2 plus 3, out 1, okay? And you can have multiple operations inside a cell, but the cell will only print out, as far as the output goes, it's only going to return one thing, okay? So each cell can only have kind of one output, and so it's going to just display as the output the result of the last operation, okay? So if I run this, it's going to, in the out, it's going to return 25, okay? On the other hand, so if you have multiple operations and you want each of these things to appear, you can call print, okay? But one thing to note is that print does not return, it's a function that returns a none, okay? So remember, if we think back to what functions do, is they take inputs and they return some kind of result. And in Python, the print function returns a none, okay? So there's actually no output. When we run this cell, it will display 9 on one line, and it will display 25 on another line. But one thing you'll notice over here is that there is no out, okay? It's not going to say out 1 or out 2. We'll have an in3, but there's nothing going to show it. There's no out 3. All right, if that's okay. So it's running these print things, but there's no output associated with this cell. Okay, there's no returned result associated with the cell. Whereas over here, the value 25 is associated with being output. Okay, and the reason for that is sometimes you want to refer back to a previous cell. So this is a feature of IPython, and you can say, you know, what did I run back in cell 1? Or what did I run back in cell 2? Or what was the output associated with cell 1 or the output associated with cell 2? So here, because we have the in 1 and the out 1 and all of that, you can call, in this cell, you can ask what was in 1. Okay, and it shows you the kind of the raw text that I input. I've got pound basic operations. This is a new line character, and on the new line I entered 2 plus 3. Okay, and then I can ask, well, what was the output associated with cell 2? Okay, and the output associated with cell 2 is the value 25. And if we just ask what is out, it's going to return back a dictionary here, okay? So it's everything that gets spit out, and it says cell 1 output the value 5, cell 2 output the value 25, cell 3 has no output. Cell 3 has no output, okay? It printed stuff to the screen, but there's no value associated with it. So that's not listed off in the dictionary. Cell 4 output this thing, and cell 5 output 25. So you have this dictionary where you have this relationship, okay? I don't know if you guys gotten to dictionaries yet in Python, and we'll talk about it. But we see dictionaries in Python. It's a very useful structure that exists in Python, and they're the closest analog we have in R would be like a named list or a named vector, okay, where you have names and things associated with them. But the dictionary is it's different. It's a structure for Python, and they're indicated using these curly braces. Okay, so if you see something with curly braces and colons inside, that's going to be a dictionary, and that associates, on one hand you have something called the key, and on the other hand you have the value. Okay, so the key 1 is associated with the value 5. Okay, so out is a dictionary, and that's why we can ask, what is the value associated with key number 2 in the dictionary out? the value associated with key number 2 in the dictionary out is the value 25, and that's what it spits out. Okay. Whereas in is a list, and it just kind of lists off every single thing that came in to into the things, right? So you've got in 1 being basic operations, and every single cell that I've run here with kind of an in shows up in this list, and it's just basically all the raw text that I've typed in. All right, and so that's a feature of IPython. It's kind of like the history of all the cells that you've run, and so if you ever need to kind of refer back to a cell that you've ran earlier, you are able to do that just by referencing the in and the out and the numbers that you see. Okay. Now, if you go back and you rerun one of these things, okay. So here I'm at in, and I'm out at in 7 and out 7. I can come back up here and I can rerun this, okay? And when I do this, this becomes in 8, okay? In number 8. And so in number 1 now has disappeared. It's not in the notebook, okay? But I can come down here and I can ask what is in, and now this has it becomes in 9, and we still have the history. We can still see what in 1 is, even though it doesn't exist. It doesn't display in my notebook anymore. Okay, and so so when you see notebooks, you can kind of get a sense of you know, the sequence in which the cells have been run, because the list in keeps track of everything. Okay, and so we left off at 7, 8 reran the basic operations, and then 9 is this thing run again, and it is a list. Okay, and if you're unhappy about this, okay, if you want to start it off at 1, you can always go to kernel restart and clear output, or kernel restart and run all. Okay, and so when you do restart and clear all outputs at the kernel, it's going to restart the kernel, and there's nothing here. And so when I run this for the first time, I get in 1, in 2, 3, 4, 5, 6, and whatever we have there. Okay, so so this kind of resets everything. So when you restart the kernel, it wipes out what was on the list in and the list out, or the dictionary out. Okay, so those things get wiped out, which is often what I will recommend that you do. So I haven't given you guys a homework assignment yet. That will come, but your homework assignment will be an IPython notebook. And my recommendation, okay, all right, maybe it's a requirement, is that after you enter all of the code and stuff that you need to do to answer the questions, after you save that, you're going to do kernel restart and run all, and that will go through and just run each cell sequentially, and all of your ins and outs will be in a nice order: 1, 2, 3, 4, 5, 6, 7, so on and so forth. Whereas, you know, as you're working, it's very normal to have a cell, it didn't do what you liked, it returned an error or something, and you go back and you edit and you enter that. And every time you basically hit Control or Shift Enter, or you run a cell, that in number will keep counting up. Okay, so you try a cell, like if I come along here and I insert a cell here, and I type in something here, some kind of error, and I try to run this, you know, it gives me an error, and I go, oh, you know what, I need to do something like this, and it outputs something onto the screen, and oh, and maybe this is not actually what I wanted. I only wanted this. And maybe this is what I want or something. So, you know, you'll see these things where it went from in 7 and then it's now at in 10 because in 8 and in 9 were wrong, right? And it didn't output exactly what we wanted. So this is a normal thing, but what you'll probably want to do is you'll want to just do kernel, restart and run all, or restart and clear cells, and then and what it will do is it will just kind of go through and and then you'll have kind of the input and output just be in a nice sequence that we like. All right, is that okay? Occasionally we will want to run a script that we have written in a separate file, okay? So, or maybe you'll download a script off the internet, okay? And most scripts that are written in Python will have a .py extension. So here I've got script1.py, okay? And so let me just show you what script1.py looks like, okay? So I'll just open this in Notepad, and this is just the dumbest script. It just says print and the string print hello world, right? So this is nothing impressive. And if you want to run something like that, okay, you can use this command called %run. This is called a magic command, and it basically tells the notebook or the IPython interpreter to run this script, okay? And so when I run it, it's going to basically run that command that says print hello world, and so there it goes, hello world, right? Okay, over here I've got script 2, okay? Script 2 says print hello plus name, okay? Now if I tried to run this, so over here I'm going to define name Miles. Maybe I will write capital M Miles here, okay? And if I try to run this, it throws back an error. It says name is not defined, okay? And so what we have to do is, if you want your script to have access to the variables that exist inside the notebook, which is what I want, because the script is very simple. I just want it to print out hello Miles, okay? And so in Python, we haven't covered this yet, but you can kind of combine strings with the plus sign, okay? So if you do hello, which is a string, plus another string Miles, it's going to combine the two and produce another string that will say hello Miles, okay? And so here I'm going to just do print hello plus the name, and I want it to use the variable name, which has the string Miles in it, and we're going to run that. So I do the magic command, magic run, %run -i, and the name of the script, okay? And so when I run that, then it works and it returns hello Miles onto the screen. So I've just run that, okay? Is this okay? All right. You can also run some bash commands, so cat is a bash command that just takes whatever letters or text appears inside a file, and it will just print it into the notebook, okay? That exists for Mac or Unix or Linux-based systems. So if I have a Windows machine, so this is not going to work because it's going to say cat is not a recognized thing. If you're on a Windows machine, you basically do the same thing, but the command is called type, okay? And so it's basically just telling me what is the contents of this file. So the contents of this file is just this one line that says print hello plus name. If I had a whole bunch more stuff, like print, I don't know, it's Friday, or something like that, okay? And I save that, I can go back, I can rerun this command, and that looks good, and I can ask it to type out the results, and it will show me the contents of the file that I ran, okay, or the file that I asked it to cat onto the screen. So that's what we have, okay? The underscore character gives you access to the last value that that was output. Okay, and that's just another nice feature of IPython. So if I do 3 times 9 and I get 27, I can refer to this last value, this 27, just by using underscore and getting underscore minus 2, and that will return 25 and things like that. Okay, and then if I run this again, then it will give me 23. Okay, and so it's just whatever you know, whatever we did last. Okay, will be the value that's stored in the underscore. Okay, and so that's IPython. I'm trying to think if there's other stuff regarding IPython that I want to talk. Okay, most of this stuff has come from the kind of the textbook that we're using, which is linked to in the syllabus, but you can just also go to Safari Books Online, proquest.safaribooksonline, and we're just going to do Python Data Science, and it's the Python Data Science Handbook. That's what we want, and kind of the first chapter is on IPython. Okay, and so IPython again is just the way our cells execute the code. Okay, so within Jupyter, all of these cells is basically you know, is interacting with the IPython interpreter, and so there's lots of things, and I'm just trying to think if there's anything else that I've missed that I want to kind of talk about, but I think I've covered most everything regarding IPython and Jupyter. Oh, so maybe the last thing. So once, let's say this covers everything that we wanted to do. Okay. You know, often I like to do kernel restart and run everything, restart and run all, and that's gonna just wipe everything out, and then sequentially it will go through and produce everything and produce all of these outputs, and then you'll kind of save it. When you close a notebook, don't just hit the little X here. What you'll want to do is you're going to want to do close and halt. Okay, because here, let me just kind of show you. If I come back over here, I have these notebooks that are in green, and we've got under the running tab, I have 2 notebooks that are running. If I come over here and I just click X, the notebook, that notebook is still running. Okay, and so the in-class demo notebook is running, so I can open it back up, and it means kind of all of these variables that I've created, the in and the out and all of that stuff, still exists in the system. So if we want to properly shut it down, you have to do File, Close, and Halt. Okay, and we can see that the notebook over here will now appear gray, indicating that it's not running and it's not keeping track of any of this stuff here. Okay, as far as homework stuff goes, I want you to upload kind of your rendered thing as HTML. So you're going to go to File, Download, and Download as HTML. Okay, and when you download it as an HTML file, then it's not going to be interactive, and it will just have, it will show, it's a little hard for you guys to see here, but it'll show kind of the code and the output, and pretty much everything that we saw in the notebook, but it's kind of static, and it's not something that changes, and it's not something that requires a ton of resources to run. Okay, because it actually, running an IPython notebook requires your computer to do quite a bit of work. So that's why I don't want you guys uploading IPython notebooks directly for the homework, but just your static rendered HTMLs. A nice thing about these IPython notebooks, however, is that once you have it saved, okay, So I'm going to go ahead and close and halt this. I'm going to come over to git bash, okay, to git, and I'm going to just ask for git status, and it's going to tell me that you know, I modified these two things, and I also created the new file 0103. Okay, so let's just go ahead and we're going to add all of our changes, and I'm going to go ahead and commit the changes, and I'll say updates at the end of class for I'll just say updates. I'll just do final updates for 01-02, 0103. Okay. So we'll go ahead and do that. And then I'm going to push these onto my repository on GitHub. Okay, so again, we add the changes, we stage them, we commit them to my local repository, and then I push my changes from my local repository to the remote repository. Okay, and I'm hoping that that sequence and process kind of makes sense now, but I think almost all of you have completed the GitHub homework assignment on Data Camp. How did that go, by the way?
A little weird.
Huh? A little weird. Okay, yeah, it's a little. Git takes a little bit of getting used to, but it's I think it's a. Of course, I'm biased, but I think it's very good. Okay, and having a GitHub that has your work, I think is a good thing. And the nice thing is that as long as your notebooks are of a reasonable size, GitHub itself can render these things directly. Okay, so here's the notebook that we just created or just saved and just pushed onto the remote repository. Okay, and GitHub takes the notebook and renders it into something that we can see, along with all of our input code and everything being output as well. Okay, if your notebook is too big, sometimes GitHub, the server, will have problems. Okay, but it's much better because if you look at the raw notebook itself, the raw notebook itself is not pretty. It will have the source and it will have the execution and all of this, and it will be written out like this, but it's not pretty to look at. Okay, but GitHub can render Jupyter notebooks most of the time, as long as they're not too big. Okay. All right, we'll go ahead and end here. I hope to see a lot of you guys at Data Fest tonight and tomorrow if you guys go there. So maybe I'll see you guys there. If not, have a great weekend. We'll see you on Monday.